Okay, guys, lesson 84. As you see up there, it's logarithmic differentiation. So this is yet another way to take derivatives. Now, this method of taking derivatives, you notice I kind of pre-wrote a couple of notes over there to the side. First of all, it can be used in place of product and quotient rule. Okay, the idea is that you use it when product and quotient rule would be rather difficult, rather dicey. And as you look at some of these, I mean, by the time we get down to example 3 down there, that's a quotient rule with 3 products on top plus 3 power rules and a power rule on bottom. And I don't even think I could do number 3 using product and quotient rules. You know, 1, I could. 2, I could. 3, I think we'd have to multiply it all out or something. It would be ugly. So anyway, so we're going to use this thing called logarithmic differentiation. Now, the one thing, and honestly, if I don't mention this, you're not even going to notice, but if you think about logs, the idea of a log is that the inside of a log has to be positive, okay? When we're dealing with x and whatever, we don't know what x is, so just as you work these, we're going to work assuming that x is a positive value as we work through it. Okay, and so again, that's just a side note that I officially need to say. It doesn't affect how we work them or anything like that. So, as we look at number 1, as I mentioned, we could do a quotient rule if we wanted to. It wouldn't be horrible, because there'd just be then a power rule in the bottom. Okay, but this is our easy one to get started. The idea of logarithmic differentiation, as you can guess, includes logs. So our first job is to take the log of both sides of the equation. Now, when I say log, officially it could be like common log, like log base 10. Or what I have written in my notes that is more common to use is natural log. Okay, I say more natural to use because we're going to have to take derivatives of all this. And when we do derivative of a natural log, what's derivative of ln x? Derivative of ln x is 1 over x, yes? If we did derivative of a log, like log of base a of x, that's a little bit more difficult. So that's why we're going to use natural log. Okay? So, step 1. Take the natural log of both sides. So, and I have several steps to get in here. Natural log of y equals natural log of this fraction, x squared over 3x plus 2 to the 4th. Officially, I just put this in brackets because we need to show that that's all inside the log. Okay, what do our log rules allow us to do on that big right log? Natural log of y, it's going to stay. We don't have to do anything with it for a while. But go back, remember your algebra 2. What does that log rule say to do when there's division inside of a log? One log with division on the inside can be rewritten as 2 logs that are being subtracted. Okay? So division goes with subtraction. That means multiplication will go with addition. So I'm going to rewrite this as the natural log of x squared minus the natural log of 3x plus 2 raised to the 4th. Are we okay with that? Okay. There's another log rule we can apply right now. Nope. We're stuck with the natural logs till we take the derivative. Powers is my hint.
Oh, okay. So move the squared out in front of the element and move the 4th out in front of it.
Okay, so if you remember vaguely, log rules, there's a power rule, and the power rule allows you to take a power and move it out front as a coefficient. So continuing along, natural log of y equals 2 natural log of x minus 4 natural log of 3x plus 2. You guys haven't helped any of my Algebra 2 kids lately, have you?
No.
Because this is what we're getting ready to test on. This has been our last chapter. Chapter 7 is logs. So 2 years ago, this is what you were learning. Just, exactly. Okay, so at this point, we're broken down into basic logs. Okay, we got our powers out front. We are ready to differentiate. Okay, in other words, take the derivative. The key is, though, I don't have just a y equals. So I can't just say, okay, y prime equals and take the derivative of everything. So we're doing the implicit differentiation where you take the derivative of each term. If there's a y involved, you tack on a dy. If there's an x involved, you tack on a dx. With our goal in the end to solve and find dy dx. Okay? So, what is the derivative of natural log of y?
dy over y.
Okay. I'm going to write it as 1 over y dy. You could do dy over y. I don't want to confuse. Honestly, I think it'll be just as good to have it next to each other. But you guys remember the derivative of natural log of something is 1 over that something, since it's terms of y times dy. Okay. 2 natural log of x. What's my derivative of 2 natural log of x going to be? Okay, so derivative of natural log of x is 1 over x times this 2 that's already out here. So are you guys okay with 2 over x? And then tacking on dx because it was an x term? Minus 4 natural log of 3x plus 2. Derivative. Four on top, because that's just already there. 1 over 3x plus 2. So 3x plus 2 goes on bottom. What else do I need? And what else do I need? Chain rule. The derivative of natural log of something is 1 over something, officially, times the derivative of something. What's the derivative of 3x plus 2? 3. So on top with that 4, I'm going to say times 3. I mean, you could technically put the 3 off to the right, yes, and put after the fraction, but you realize that we're going to end up putting it on top at some point. Okay, 1 over y times dy, I'm good with for the right now. What I want to do on the right is I want to factor out this dx, because eventually we're going to want dy over dx. So I'm going to factor out my dx on the right, meaning if I factor out that dx at the end, I'm still going to have a 2 over x as my first term, minus my second term, which is, I wrote it as minus 12 over 3x plus 2 times dx. You see where we're going with this? Right. We want it to be dy over dx, which means we're going to keep the dy on the left. We need to divide the dx over, yes, to get our dy over dx. That means this 2 over x minus 12 over 3x plus 2 is going to stay where it is. How do I move 1 over y to the other side? Times by y, right? If you have y in the denominator, to get to the other side, I'm going to multiply the y over. So it's going to be, if I multiply that y over, it's y times what was already there, the 2 over x minus 12 over 3x plus 2. We have one last step to do to call it done. I was giving people a moment to
distribute the y.
No. if this,
Same denominator.
no? Are we okay with what I did to get to here? That's why I was kind of waiting.
Oh, are you changing y?
Yeah. So we had dy here. We wanted to get the dx over, so we divided the dx over. That left my parentheses there. The 1 divided by y, we multiplied the y to the other side. Now, if this is dy dx, that means I need my derivative all in terms of x. I have mostly x, but then I also have a y. What was y originally defined as? Y is equal to what?
X squared over 3x plus 2 to the 4.
Okay, so we're going to take, right here where there's a y out front, we're just going to replace it with this fraction right here. We're not going to do anything past that. We're going to leave this ugly, which is good news, but we're just going to replace it. So, dy dx equals y. Okay, my y is x squared over 3x plus 2 raised to the 4th times what was already there of 2 over x minus 12 over 3x plus 2. It's not pretty. It doesn't have to be pretty. Enjoy the fact that it's not pretty and you don't have to make it pretty. Right? Because if you were doing this quotient rule, it would not be pretty. It would be a totally different form if we treated it as quotient rule. But, okay. Got the gist of it? Maybe. We'll see what happens when we try and do it again.
Okay.
I say it's not that it's horrible by any means. I mean, it's just different. It's also not like a two-step problem though either. I mean, you know, it's not horrible, but it's not real quick steps either. Okay. So, example 2. Look back up above. What's step 1? Natural log of both sides. So, natural log of y. That's the easy one. Natural log of x cubed times the square root of x squared plus 1 over x plus 2 raised to the 6th. How daring are we? How much can we do all at once?
The whole problem. No more step.
Well, you need to shift the 3 out front first. Well, when you split it, you're gonna have a plus. You're gonna have positive, positive, negative.
Okay.
What?
So,
X to the third and the square root. Yeah. It's multiplied.
okay, so
Right?
we have to split these logs up, right? First of all, there's 2 pieces on top being multiplied, yes? And then a piece on bottom being divided. So how many logs am I splitting this up into? 3. Because the 2 on top will be added, and then the 1 on bottom will be subtracted, yes? And then, what else do all 3 of these logs have? Well, what will they have on them? They'll have to move.
Exponents.
They all have exponents, right? So when we do log of x cubed, you can either write it log of x cubed and then take another step later, or move the 3 out front. So if you want to do this all in one step, we can. What's that square root? That square root is a power of a half. And on bottom you have a power of 6. So, okay, so we first have natural log of x cubed, which I'm not going to write natural log of x cubed. I'm going to do 3 natural log of x. That represents natural log of x cubed, right? Then I have this piece being multiplied on top, so I'm going to add. Okay, it's natural log of the square root of x squared plus 1. So that square root is going to come out front as 1/2 natural log, and I'm going to put parentheses around x squared plus 1. And then we're going to minus the log on the bottom. and it has a power of 6, so minus 6 natural log, parentheses, x plus 2.
That wasn't that bad.
I mean, if you can do that all in one step, it saves you having to write it out a couple of different times. I didn't do that the first time through because I had to remind you our log rules we haven't used in 2 years. Or maybe we use them in pre-cal, I don't know, but not a whole bunch, so. Okay. So what was my next step after we got all of our logs separated? Okay. We've got to take our derivatives. So, what is a derivative of natural log of y? Derivative of natural log of something? Yeah. So in this case, 1 over y times dy. 3 natural log of x. So what's the derivative of natural log of x?
3 over x.
Yeah, it's the 1 over x. We already have that 3. Chain rule doesn't do anything for me here. So 3 over x dx plus.
You're going to have a chain 2x, so the 1/2 cancels with the 2.
Okay. If I write it out as a step here, and then I'll clean it up next time. There's already a 1/2, yes? What's the derivative of 1 over? What's the derivative of natural log of x squared plus 1?
2x over x squared plus 1.
Okay,
Because you have to bring the 2.
right. Officially, we would start off by saying 1 over x squared plus 1 times the derivative of x squared plus 1, which is the 2x, so that puts 2x on top. And that was all in terms of x, so this is a times dx. Now, do you see what Jack was saying, that the 2's would cancel? Yeah, the 2's will cancel. So you're just going to end up with x over x squared plus 1. Minus 6 natural log of x plus 2, that derivative.
6 minus 6 over x.
Okay. 6 goes on top. Derivative of natural log of x over 2, or x plus 2, it's 1 over x plus 2, times the derivative of x plus 2,
1.
just 1, right? But technically we should always consider it. I'm bad about forgetting to make you guys think about it. And then times dx. What did I do next? Okay. And I don't know. I'm going to. You may or may not need to. I'm going to go ahead and factor out that dx if you haven't already. But I agree. It's, whatever steps you need to physically write down to get there. So if I write it as 1 over y dy for the moment, and I take my right and just factor out that dx, that means I still have a 3 over x plus my 2's cancel. I just have x over x squared plus 1 minus the 6 over x plus 2, and then times dx. Your goal is to get this dy dx, right? dy is already on the left. We need to divide the dx over and times the y over. So dy dx equals y times 3 over x plus x over x squared plus 1 minus 6 over x plus 2. Final step, replace y if you haven't already. And I get, could you combine some of these steps depending on where you're at? Definitely. Some of you'll be, combining steps, some of you won't be. I'm going to write it right here. dy dx equals, what was my y? Oh, it's that fun thing. X cubed square root of x squared plus 1 over x plus 2 to the 6th times 3 over x plus x over x squared plus 1 minus 6 over x plus 2. Just me, it doesn't sound like there's a party next door today.
Well, there's probably a lot of sophomores in there, and they just came from Weston.
Valid point.
Yes.
Valid point. And since he didn't get to do anything with his morning, although this is AP this period, but. Okay. Ready for the next one?
Yep.
Let's do it.
When I know how to do stuff like this, I enjoy it so much more than when I'm like,
I get it. I enjoy teaching it a lot more when it's something that is doable and you guys can follow. And okay. So, first thing, natural log of y equals. Can we break it all up right off the bat, or do you want me to write natural log of that big ugly fraction?
1/2 ln 3x.
So Jack's saying break it up.
If you're starting.
Can we do that?
yeah.
I'm all about it, because why do I need to write natural log of that? Exactly. So, okay, the first one is natural log of square root of 3x plus 2. That square root goes out front as a 1/2. So 1/2 natural log of 3x plus 2. See, it's enjoyable too when you guys see that stuff and you'll let me go that way. But if you don't see it, then I won't go that way. The next one, we're going to add because it's multiplying. There's a 4. 4 natural log of x cubed plus 1.
It's plus 2 of ln 5x.
Got another multiplying, so we're going to add. Move that power of 2, so 2 natural log 5x minus 3. Denominator says we're going to subtract 5 natural log of x cubed minus 2. Okay. What's my next step?
Take the derivatives.
Okay. Now, on the left, the derivative of natural log of y.
1y over d.
1 over y dy. Here's another step if you'll let me combine things. As we take, all these terms on the right are in terms of x, yes?
Yes.
Could we go ahead and wait and put the dx at the end? I'm trying to combine steps as you guys get more confidence here. Especially because this one, I don't want to write this one out a bunch of times. What can I say? I'm as guilty of that as you guys are. How many times do we want to have to write all this stuff out?
That's exactly what I did.
Okay, so there's a 1/2 here. Derivative of natural log of 3x plus 2.
3 over 6x plus 2.
Okay, so we've already got the. Okay, so I heard the 1 over 3x plus 2, yes? But it's going to be times the derivative of 3x plus 2. What's the derivative of 3x plus 2? 3. So I'm going to put a 3 out on top. And what also has to be in the denominator?
1/2.
There's that 1/2 out front. So I'm going to multiply that 2 by my denominator. You can write it as 2 times 3x plus 2. Or you can write it as 6x plus 4. Whatever makes you happy. Okay, that's my first term. Plus 4 natural log of x, is that cubed?
Yeah.
Plus 1. Sorry, I can't read my own handwriting. Okay, so the 4 goes on top, because that one's derivative of natural log of this term
3x squared.
means on bottom there's going to be x cubed plus 1, because it's 1 over x cubed plus 1, times the derivative of x cubed plus 1, 3x squared. So that will end up being a 12x squared in my next term.
You're going to have 10 on top.
Plus I'm going to put 2 on top. I agree, though. Derivative of natural log of 5x minus 3. 1 over 5x minus 3 times the derivative of 5x minus 3, which is 5. And by all means, combine these if you want. My thought is I want, as you look back at it, to be able to figure out where these pieces came from if you're a little unsure. Minus. There's a 5 on top. Derivative of natural log of x cubed minus 2. 1 over x cubed minus 2.
Times 3x squared.
Times the derivative of x cubed minus 2, which is 3x squared. I'm ending at, I put parentheses around the entire thing. Dx. Okay. We need to solve this for dy dx.
You're going to be multiplied by your y terms.
Can we just go ahead and put the y down here instead of writing y times all of that?
Do you want me to?
Or can we just skip to writing the y function?
I think that's what she was asking.
Oh, okay. So
Different way of saying it, but that was the impression. Okay, I was going to write y, but you guys would rather me just go ahead and
Write it now.
write it now? I can do it. Okay, so y is, that fun thing.
put an arrow that says that.
That. Square root of 3x plus 2,
How would they learn to put that on?
x cubed plus 1 over 4 times or raised to the 4th, 5x minus 3 to the 2nd, all over x cubed minus 2 raised to the 5th. And I'm going to underneath put, that's why. Just, I'm good though. Times. Basically just clean up the stuff we had from before, right? It's 3 over, I have 6x plus 4 written in my notes, but if you write it as 2 times 3x plus 2, I'm good. So 3 over 6x plus 4 plus 12x squared over x cubed plus 1 plus 10 over 5x minus 3 minus 15x squared over x cubed minus 2.
Oh, we're going to do the same thing with y equals x to the x.
Kind of.
What did you say? Y equals x to the x.
Yes.
Yeah, that's the next problem.
Oh.
I swear I'm not crazy.
Yeah.
Yeah.
Okay, you're talking about we just did not.
Yeah. Now, comparison factor. We just did 3 steps on the biggest problem so far compared to, I wrote 7 steps out on the first one. However, if I had just done 3 steps on the first one, I'm not sure you guys would understand it as well. Like I needed to break it down. Okay. So example 5. Let y equals x to the x. Find dy dx given that the domain of the function is a set of all positive real numbers. So basically, find dy dx again. This one's slightly different. There's a slight catch in here. So first step. Yeah.
ln y equals x ln x.
Okay. ln y equals natural log of x to the x. Are you guys okay with moving the x out front? So we did, yeah. So x ln x. Take our derivatives. Derivative of natural log of y. 1 over y dy. Derivative of x natural log of x.
ln x minus 1.
Are we going to do because that would have been a 1 over x. So does that mean the exponential on top is just x over x?
You're going to product rule it.
That's
So that first x drops off on the first term.
He's got a sign mistake in yours, though.
Oh, it's plus.
Okay, so X is a variable term, yes? Natural log of X is a variable term. It's different if that's, say, 3 natural log of X. 3 is just a constant. So it's one derivative. But when it's X and it's natural log of X, those are two things that we have to take derivative of. So we have to use our product rule. So even though we were trying to make life easier, we're using our product rule. Which in reality, though, we don't have a rule for X to the X. You know, product rule, quotient rule, we don't have a rule for X to the X. So it's a whole new thing. Yeah. So, remember product rule. Derivative of the first times the second. Plus, keep the first, derivative of the second. So, what's the derivative of X? 1 times, we're going to keep natural log of X. Plus, this time we're going to keep the X times what's the derivative of natural log of X? 1 over X. And then tack on the dx. Okay, rewind.
I looked away for 1 second.
You can't look away for a second in calculus. Don't you know better?
Don't blink, Cassie. Don't blink.
Okay.
Well, I don't just go ahead.
Okay.
I dropped something.
Okay. Sorry. Product rule.
Yes.
Derivative of the first, keep the second. Plus, and then flip-flop that.
Okay.
So derivative of X, I even wrote the 1, which I don't normally do, but I did for this case. Derivative of X is 1 times keep the natural log of X. Then because it's product rule, we add. Now I keep the X. Derivative of natural log of X is 1 over X. Come on. We're like 3/4 of the way through this year. You know you can't look away. Okay, I'm going to clean this up a little bit. It's small. I don't care if I write a few extra steps. 1 times natural log of X is natural log of X plus X times 1 over X. There's that 1 you guys wanted. Dx. You know how to finish from here? Or am I going too fast? We're going to make it dy dx. So we kept the dy, we divided the dx over. We're going to multiply by y out front. I know what you guys are going to tell me, I think. Y is x to the x times the ln x plus 1. Okay. Got it? I think we have one more to do.
All we need to do is just dy over dx. We
Uh-huh.
don't have to solve for like anything else.
No, the directions, find dy dx, and then, so it's just like the others, find dy dx, given that the domain of the function is a set of all positive real numbers. So they were just restricting the positives.
Oh, okay. I read it wrong. I thought it said something about find out.
No, given that the domain. Big difference.
Yeah.
Okay. This next example is going to be similar to the one we just did, if I recall correctly. This time it's y equals x to the x cubed plus 4. Find dy dx. So, step 1. Yeah. Natural log. So natural log of y equals, what's happening on the right? We take the natural log of that side. Okay. X cubed plus 4, natural log of x, because we pulled that power out front. Derivative of natural log of y. 1 over y dy. What's happening on the right side?
You need maybe.
Is there stuff the front or divided in half to be feminine?
Okay. So I was just going to go jump right into product rule right here. It would work out the same in the end. Jack suggested distribute here, which is why I was pausing to think. So Jack's saying take ln x make it ln x times x cubed, which you're going to have to use product rule there, plus 4 ln x. Whereas I was going to go ahead and treat this as a product rule right here. It'll all work out the same in the end, I promise. Okay? Honestly, I'm trying to figure out which is better. I'm not sure that there is a better. I think it's which one do you see and makes sense to you?
If we were to do, you said we don't have to still use product rule again though?
You're going to have to use product rule when you do the ln x and x cubed. Yeah, you would. You'd have to use the product rule in there. So, again, I'm trying to figure out which one's better, and I don't know. So, okay, let's go with this way. If I'm doing my product rule, derivative of x cubed plus 4, 3x squared, and then we're going to keep the ln x. Plus, now I'm going to do keep x cubed plus 4, which I'm putting in parentheses, times derivative of ln x, 1 over x. And then this is all officially times dx. I am going to have to clean it up, so I guess this is where I'm going to do my distribute here, whereas you already distributed. So that's probably the one difference. Because I would say we want to distribute this 1 over x to the x cubed and the 4. So, no, don't do that. Should I go ahead and clean this up?